the James Webb Space Telescope. The most advanced instrument known to man for examining the universe has not yet revealed another monumental revelation. The newly unveiled imagery of Pluto is changing every assumption that we had formerly maintained about this icy celestial body, revealing secrets both awe-inspiring and profoundly provocative. Previously dismissed as merely a frozen, lifeless ball on the periphery of our solar system, Pluto now reveals itself as substantially more intricate and vivacious, exhibiting indications of hidden motion, tectonic transformation, and intricate chemical structures that defy current interpretation. These landmark discoveries have left researchers in a condition of wonder and perplexity. At the heart of this renewed comprehension resides Sputnik, the well-known heart-shaped planitia domain on the surface of Pluto. What was once thought to be a single sheet of nitrogen ice is now believed to conceal a substantial surface ocean. Beneath its frigid exterior, surrounded by dense ice, this enormous reservoir of water could rank among the most pivotal breakthroughs in the quest for existence on other planets. Shielded from the severe space conditions, scientists are now considering the prospect that there may be microorganisms in these hidden reaches. Pluto's interior constantly astonishes investigators. Towering peaks covered in ice, with altitudes comparable to Earth's highest mountains, climb high, while expansive flat plains maintain a spotless appearance, implying a new geological development took place comparatively recently. This active geology was completely unexpected for a world that was once thought to be geologically inert. Heat generated from Pluto's core reactivates convection below its frozen shell, causing the nitrogen ice to move slowly, akin to cooling lava in a lava lamp. These occurrences depict a region far from desolate. Pluto, as shown in these unveiled images, is brimming with vitality. Despite the vast distance from the Sun, Pluto now joins a growing number of icy moons and worlds, such as Europa and Enceladus, that may support life under their external icy layers. Organic substances and water could engage in heated interactions, fostering the chemistry of prebiotics. Even if there are no advanced organisms, existence of microorganisms on Pluto would significantly alter our idea of habitability throughout the cosmos, proving that life can endure in environments once deemed uninhabitable. Pluto's connection with Charon, its satellite, is unique within our planetary neighborhood. Nearly comparable in size, the two bodies influence each other gravitationally, generating internal heat and launching dynamic modifications on both. Charon likewise conceals its own enigmas. Profound trenches and a peculiar reddish tint suggest that material from Pluto's surface may transfer to Charon, signaling a chemical interchange that could encompass life's requisite ingredients. None of these remarkable breakthroughs would have been possible without the James Webb Space Telescope. Its ultraviolet detection permitted astronomers to peer beneath Pluto's frozen crust, uncovering details earlier missions overlooked. By examining the terrain of Pluto and atmospheric layers, the Webb telescope detected heat and organic molecule variations, presenting a vision of an unexpectedly animated world. Pluto's atmosphere, albeit tenuous, is extremely detailed and composed primarily of nitrogen with traces of both carbon dioxide and methane. It forms a delicate haze extending hundreds of miles higher than Earth. As Pluto travels in its pronounced elliptical orbit, its faint atmosphere undergoes dramatic shifts. Surface ice thickens closer to the Sun, transforms into gas, and produces a temporary envelope. As it recedes, this envelope refreezes onto the ground, creating a unique cyclical pattern unlike anywhere else within the solar system. These atmospheric cycles grant rare insight into planetary adaptation to extreme settings. One of the most striking features on both Pluto and Charon are their surfaces' reddish streaks. It is believed that these areas are covered with tholins, complex organic compounds generated when ultraviolet radiation interacts with methane in the atmosphere. Tholins not only endow the surface with its hue, but also hint at the emergence of pre-life chemistry, an elemental chemical root that could lay the foundation for biological development. Academics are especially fascinated by the potential of these substances to interact with water ice in the subsurface. Could these tholins act as rudimentary life precursor units, transported into the secret ocean that can be combined with other organic molecules? This captivating inquiry is one scientists are keen to investigate. One of the most revolutionary discoveries about Pluto is the probable presence of an expansive ocean beneath its icy exterior. This ocean, preserved in liquid form by geothermal warmth from radioactive decay in Pluto's core, could take up a significant portion of the planet's interior. On Earth, hydrothermal environments like deep-sea vents teem with life. If Pluto's clandestine ocean offers comparable conditions, it might sustain microbial ecosystems, or perhaps something more advanced. Uncovering Pluto's hidden depths might revolutionize our perspective on where life can flourish, demonstrating that even the least likely realms can harbor vital phenomena. The publication of photos, as well as information from the James Webb Telescope, has sparked a great deal of enthusiasm and conjecture. Governments, academic bodies, and the general public are all captivated by what Pluto's depths may reveal about the larger universe. Pluto was not considered a largely unimportant world. Yet, these novel findings demonstrate how little we truly comprehend about our celestial counterparts. With each new set of data released, expectancy mounts about numerous unanswered questions. The accomplishments delivered by the Webb telescope only depict the dawn. Orbiters and landers are intended to probe Pluto more profoundly. These missions might verify the reality of the subterranean ocean and furnish the first direct indications of life beyond Earth. Some have even suggested dispatching robotic submersibles into Pluto's hidden sea, an incredible feat of engineering that would establish itself as one of the greatest accomplishments in space exploration. As technology progresses, the aspiration of directly examining the depths of Pluto gradually becomes achievable. This endeavor could radically alter our comprehension of the cosmos in unimaginable ways. One of Pluto's deepest enigmas is how it maintains geological vitality despite its vast distance from the Sun. Pluto produces sufficient internal warmth to drive convection in its icy mantle, as well as support an underground ocean. This heat probably comes from radioactive decay over eons, releasing energy from its core, as well as interactions with the tides from Coron. This internal heat may clarify the unexpected geological vitality of Pluto and a subsurface sea that endures. Although Pluto lacks a potent magnetic field akin to Earth's, it still interacts with the solar wind in distinctive fashions. Parts of its atmosphere are destroyed by these interactions, generating a torrent of ionized particles drifting into space. The JWST has observed unusual magnetic and energetic phenomena in the vicinity. Pluto implies an interplay between its magnetic environment and the Kuiper Belt. These insights supply a rare perspective on how dwarf planets and small mapades and small bodies interact with their magnificent surroundings. The disclosures concerning Pluto are just the curtain raiser. With missions aiming beyond the Kuiper Belt, humankind stands ready to explore the farthest reaches of our planetary system. Pluto has pioneered new pathways, proving that even the remotest stories await in the world's discovery. As technology matures, the dividing line between science fiction and reality continues to blur. From autonomous submersibles submerged below frozen seas to primitive missions into the Kuiper Belt, Pluto reminds us that the universe is boundless, mysterious, and overflowing with awe-inspiring wonders. Once thought of as a frozen, lifeless speck, Pluto has demonstrated itself to be anything but ordinary. Its active geology, atmosphere of mystery, submerged oceans, and organic components challenge all prior notions of the outer solar system. The James Webb Telescope's breathtaking visuals and pioneering discoveries have transformed Pluto from an obscure oddity into a central subject of scientific investigation. These revelations caution us that enigmas persist even in the farthest reaches of the solar system we have. Looking forward, Pluto stands as an emblem of optimism and inquiry. Its secrets remain hidden, inspiring fresh missions, groundbreaking innovation, and novel inquiries regarding our position within the universe. Could Pluto support life? What other wonders might lurk beneath the ice? What lessons can it reveal about our ancestry? Pluto's narrative is far from complete. With every insight, it brings to mind the staggering dimensions of the universe, hidden depths, and an endless supply of surprises, provided we dare to pursue their finding. What are your reflections on the James Webb Telescope's disclosures about Pluto? Do you believe it could preserve life or conceal profound wonders for which we have not yet prepared to unveil? Share your perspectives below, and if you want more enthralling cosmic tales, please subscribe. The route taken to decode Pluto's enigmas has only begun. With each revelation, humanity's comprehension of the world's planets expands. The James Webb Telescope has opened the door to a world we once thought we knew, only to uncover that Pluto is a complex, dynamic realm that holds secrets we are only embarking on decoding. These revelations resize our conception of Pluto and challenge our convictions regarding life beyond Earth as we persist in exploring Pluto's terrain, atmosphere, and concealed territories. Forthcoming missions aim to confront some of the most vital questions regarding its ability to sustain life. Could the ocean beneath its frozen crust shelter microorganisms or even more intricate ecosystems? Could Pluto's peculiar atmospheric rhythms shed light on the evolution of far-off exoplanets? This ongoing scientific endeavor is essential for dealing with these and countless additional inquiries with the potential to reshape how we conceive habitability on other worlds. In concert with the JWST's initiatives, supplementary scientific instruments and exploratory missions will expand our insight into Pluto. Spacecraft in orbit will offer new viewpoints, while landers and prospective rovers may extract surface specimens. Later missions may verify the subsurface ocean directly, demonstrating that life can subsist in the most improbable conditions. Poised to reveal more about Pluto's geology and atmosphere, explorations on the horizon promise not only for this dwarf planet, but for revealing larger cosmic mysteries. As technology evolves, we may witness the deployment of robotically controlled submersibles beneath Pluto's icy shell. It's an epic milestone in space exploration that would give humanity the power to investigate one of the most remote, mysterious worlds with unlike precision. Pluto's peculiar and unpredictable behavior continues to perplex scientists. In spite of its remoteness, it causes internal heat that stimulates geological and atmospheric processes. That warmth derived from radioactive decay in its core aids in explaining ice migration on its potential subsurface and surface ocean. The interaction of gravity between Pluto and Charon is similarly responsible for this internal heat budget. Tidal flexing helps maintain geological motion. It's intense scrutiny into Pluto's geology and atmosphere. It's changing the way we think about planetary maturation in the frigid depths of space. The fact that Pluto remains so lively under extreme conditions defies prevailing assumptions, signaling that our knowledge of what is possible beyond Earth is still incomplete. Powered by the groundbreaking JWST discoveries, the continuous search for life on distant worlds will shape the upcoming space exploration epic. Whether it's microbial life on Pluto, hidden oceans on other satellites, or habitable environments beyond our planets, the search for defining the conditions necessary for life in the universe is just beginning. As we expand our horizons and learn about new celestial domains, Pluto remains the center of scientific interest and deliberate discovery. In summary, the James Webb Space Telescope's unlocked revelations are merely the beginning of humanity's journey to comprehend the cosmos. Pluto, once considered a chilly, lifeless outpost, is now regarded as a lively, energetic world brimming with unanticipated characteristics. As investigations continue beneath its surface, atmosphere, and secret waters, Pluto may contain solutions to some of science's deepest inquiries, yet its mysteries are far from fully deciphered.